Hello again, it's Cliff here from Down Under. Here we have part 2 of work and tool offsets for Rapidturn. If you haven't seen part 1, I suggest you go back and watch that now, because I'm going to be getting in fairly deeply halfway through the concepts of work and tool offsets. Cheers. Well, that's come out really well. Pleased with that. Okay, so with this video, which is about work and tool offsets for Rapidturn, I mainly wanted to go into understanding offsets better, tool offsets better, and I used the example of tool 1 to set the work offset, but it doesn't have to be tool 1. It could be tool 27. And tool 27 would be quite a good choice in some ways because it's not available here on the work offsets table, and so it's not possible to accidentally use an existing tool or with values that you don't want in there. But I've used tool 1 because Daniel Rogi's excellent video. I'll just reiterate what it is again. Cutting your first part on a Tormac lathe. He goes over the concepts of work and tool offsets very clearly, and I want to have best practice and just use the same examples that he's used. So I'm using tool 1, but it isn't critical that it is tool 1. It could be tool 2 or tool 27. It can't be tool 0 because there's no tool 0 available. And if I put in tool 0, T0, enter, we get a not found in tool table. Now that's confusing because if you're operating in mill, you can enter tool 0. Even though there's no tool 0 in the tool table, you can enter tool 0 in the mill, and that's quite useful because it will have no offsets set on it. It's a little bit like using tool 27 in lathe, and I imagine Rapidturn is the same as Slant Pro here, but I'm just guessing because I don't have a Slant Pro. Okay, so don't get hung up on the fact that which tool's your master tool, which tool has no offsets. I'm just following the example to keep it simple. We don't want to get too involved in the theory of what's going on with the software and the offsets. Now, if you look at another Tormac video on work and tool offsets, it's a Tormac video by Mike Corliss, and it's called Tormac CNC Lathe Setting Work and Tool Offsets. He has a slightly different way of doing it. For a master tool, he uses a part of the machine that isn't an actual cutting tool. He uses the body of a quick change tool holder. You could also, with a Rapidturn gang tooling setup, you could use the corner of a gang tooling block, or the bore of a gang tooling block, or the corner. It doesn't matter where, you just have a point. Now the advantage of having a non-tool edge for your reference, for your work offset, is that you can find it back again irrespective of whether you still have that tool in there, or whether it's been sharpened, or whether the tip's been replaced, or the tool's been shifted. So what he uses for his master tool position is something like this, and that's worth considering for certain types of work. It could be an advantage to call that tool 1 master tool no offsets on the tool table, you move from your reference position to that position and set 0, 0 on your main DRO screen. And you might want to call that tool 1 or tool 27, but just stick to it, whatever you decide to call it, and there'll be less confusion in the future. Okay, a couple of other grey areas. I've just indexed back the parting tool, tool number 2, to the end and centre of the work. Okay, let's say you want to make an adjustment to the position. Let's say you're parting it off and it's a little bit too long and you want to make it a little bit shorter. I know there's a lot of confusion over that subject as well. So if we go to our offsets page, we're currently on tool 1. Now be careful here. You need to reselect the tool you're on. I'll just do this by the most simplest method. So we're going to reselect tool 2 before we make the adjustment. Now there's different ways we can make it. So we're currently on 0, Z0. Let's make a big amount so it's nice and easy, because we're only talking concepts. Alright, so rather than entering it in the DRO, I'm just going to actually move it. So now we've moved it 4 millimeters here and it's showing on the DRO. Now we're not going to change that setting, because if we change that DRO setting, we're going to change the work offset for all the different tools, and we don't want to do that. We just want to change that parting tool position. So we enter tool 2 and we change it to the new position, 0, enter. Now it's gone to 0 there. We've changed it via this method, and that means it will have updated here. So what it's done is it's changed the offset specific to that tool. So the relative difference of the offsets between the tools has now changed. If we had made the mistake of changing it here, we would have changed the position of that tool, but we would have also shuffled all the tools because the relative difference would remain the same. And I think this is a concept some of us get confused over. I know I did in the beginning. We can think of all the tools in the tool table as all being tied by these offset amounts in the X and Y, and in the mill in the X and the Z, and in the mill X, Y and Z. But in the lathe it's X and Z. They're tied by those amounts, and if we want to change the relative position, then we must go and change it either here, which is a kind of a nice user-friendly facility, or we could actually enter it in here, but I wouldn't advise that. So we would change it via this facility. Now if it's a tiny amount, you know, talking 1 thou or 2 thou, we can enter it in as a wear value. So we might want to go in here, and let's say it's 0.2 of a millimeter. It hasn't let me do that because I've entered it incorrectly. 0.2, we need to delete out some of that. Now it's showing as a plus value, which is in red, and it's what we then have are an offset value that's not changed here. The relative values are all the same, but that little wear value is added or subtracted to the offset values. So it's like another tool table in the X and Z wear of minus and plus values that add or subtract to the existing tool values. Now if we put in a minus value there, it goes to blue, showing minus. That's a really nice feature. Okay, while I'm touching on the wear offsets, be careful there, because what you need to do with the wear offsets, if you're using this very convenient facility to have an additional tool table effectively, is to make sure that your code, you know, if you're running conversational code or you're hand coding, make sure your code identifies that you want to use wear offsets. So you would go Tool 2 02, enter, and see we've got Tool 0202, and the second 02 tells the software you want to use that wear offset. So when you come to run the part, it'll look it up and say, okay, there's a -0.2 factor we've got to factor in. That's handy because when you're sizing your part, as the machine warms up or cools down, you can change that, and as long as your code calls up that number, then whatever you enter in here, it will adjust it on the fly from part to part as you settle in to meet the required accuracy of your job. Okay, so just reiterating one of those points. So you come in the morning, your machine's been switched off overnight, it's a lot colder, you reference it, open up your file, run your first part and measure it, and all of the dimensions have shifted slightly because of the temperature difference. You want to make an adjustment to fix them all. You don't want to have to individually reset all of the tools. Well, then you would go to, for example, your master tool 1, if you're using that system, and change the DRO here by that small amount. And what that will do is shift all of the offsets by that small amount. And let's say it's 2 thou different. You would change your DRO or shift the work in the direction you want to go, and re-zero the DRO, which is probably safer. It's less likely to get your plus and minus mixed up. And then all the different offsets will shift. They'll all remain connected. But if you run the first part and one of the dimensions is out, and you just want to change one of the tools, then you would select that tool number and just make the change on that tool. Go to the position, for example, and change that tool, or make an adjustment via the X and Z wear offset. Just reiterating again, so if you come in the morning and you run your first part, and there might be a thermal change, but there might also be a change due to a homing error. I mean, most of you will know that the homing micro switches are just basic roller operated micro switches, and they will only re-home or re-reference to within 1 thou or 2. And you might have got a bit of swath on the roller that intermittently changes the homing position by 5 or 10 thou. And so again, you want to change all of the tool offsets to accommodate that homing error, but you don't want to change the relative difference between the tool offsets, so you would make that change via the main DRO. Let me try and explain this with a schematic drawing. I'm just drawing up now our setup. So okay, here's our vertical column, here's our tooling platform, here's Rapidturn, there's our work. We've got a pointer referencing showing the X, Z center point there. We're using in green a master tool. Let's call it a green master tool with a pointer showing the control point touching the key point on the work. We're showing our homing switches here in the vertical, which in the lathe form is the X, and the longitudinal, which in the lathe form is the Z. Okay, so let's just have a look at this. When the machine is homed, the homing micro switches are in contact, and when that's in contact there, and that micro switch is in contact there, the machine is referenced in its G53 0 position. So the machine is referenced or homed, and the X and the Z slideways are at their X0, Z0. Is it coming through okay there? Alright, now let's say we've got a master tool that's a pointer, and when our master tool or tool holder. If you're watching Mike Corliss's video, he uses a corner of a tool holder. When our master tool is a pointer, and when our master tool or tool holder position is touching the end of our work, that's this position here, we say our G54 work offset is set, and our G54 coordinates are 0, x0, z0. That's the G54 0, 0 position. Okay, x0, z0 in that position. We could call this our operator's home position, or our operator's referenced position. So we've got to remember that these terms like machine coordinates, work offsets, referencing, homing, tool offsets, they're just CNC nomenclature that have evolved over time. It's a system of terms and names that have evolved over time, and inevitably in some situations these terms have become confusing and are in some situations misnomers. So we need to keep that in mind. We don't get too hung up on it, because there's machine tools have developed, and coordinate systems have developed, from the early screw machines to digital readouts to multiple offset digital readouts, now to CNC machines, and now we have Rapidturn, which is a sort of half lathe, half mill. And some of these terms are a little bit of a misnomer. The nomenclature is a misnomer. It's sort of a misname, if you like. So we probably pay to use several different names. So let's say the G54 position, the X0, Z0 is our operator's home position. And the offsets are the distance values stored in the tool tables. So the other tools, okay, I've drawn another tool here, just diagrammatically. That's just a conventional turning tool. And they're installed in different positions. Now, if you've got conventional quick change tool post, then it'll be the different positions of the different tool holders when they're put in the tool post. So the other tools are installed in different positions in the quick change tool post or on the gang platform, as in my situation. And the distances from their cutting edges, or the control point, from this point to the control point of the master tool, is the tool offset distance from that G54 position, or the operator's home position or reference position. I'm using different terms because of the risk of term misnomers here. And probably the key subject that we're all interested here is tool offsets. And tool offsets, for example, this X and this Z, are distance values that are stored in the tool tables and can be thought of as a linked group. And they're permanently linked by the tool tables. And all the time those values remain in the tool tables, the software has them as a linked group. And while we're mainly concerned about the tool offsets from our G54 operator's home position, G54XZ0, the computer and the software are also interested in the distance from the G53.0, where the home microswitch is, to the G54.0 that we've set up, keeps that in mind and adds to it the tool offset that we're currently running through the NC code and any wear offset. So there's 3 distances per coordinate, and there may be 3 or 4 coordinates. So our software is working overtime doing all of that for us, and we're mainly concerned about the tool offsets once we've got our G54 operator's home set. Of course, this is just one way of looking at it schematically. The software just uses all of those numbers and adds and subtracts them appropriately. And you may have not ever conceptualized it in that way. You may be happy just entering the values into the tool table and you have your own way of understanding it. And as long as it works, that's fine. There's some of us that are confused about this. I know from looking at the different threads on forums and having it sort of pictorially, geometrically laid out will help to clarify it for them. For others, this won't help. And I apologize if you're one of those. Alright guys, that wraps it up. Thanks for watching. Cheers.